Hello everyone. Today we will learn about the finite integral as the limit of a sum. Let us consider a coordinate axis and let there be a function fx. Now you see, with the help of integration and with the definite integral, actually we can find the area under the curve. That is, whenever we write integration from a to b f of x dx, actually we are finding the area under the curve from point A to B. So let us consider a point A on the x-axis and point B on the x-axis. And if I have to find the area under this curve within this A and B, then we can find this area using the limit sum also. For that purpose, let us distribute this area with small rectangles. So let there be n number of rectangles which could cover the area under this curve. And if the breadth of each rectangle be h, then we know that area of the rectangle is length into breadth. So here, in order to find the area of this particular rectangle, the length is this much here, that is f of a, because this is the functional value which we have here. So this is f of a. So the length of this rectangle is f of a and breadth is h. So multiplying f of a into h, we find the area of this first rectangle. And in order to find the area of this second rectangle, the length here is f of a plus h, because this point is a and this point is a plus h. So the functional value corresponding to this is f of a plus h. So that means this value is f of a plus h. So the length for that rectangle will be f of a plus h into the breadth is again h. Similarly, in order to find the area of this third rectangle, it will be length into breadth. So that is, the length will be f of a plus 2h and the breadth is again h for this rectangle also. So similarly, finding the area of all rectangles up to the nth rectangle, here the area of nth rectangle will be length into breadth. Since this point was a, this point was a plus h, this point was a plus 2h. So similarly, this point will be a plus n minus 1 h. So the corresponding value for this particular point will be f of a plus n minus 1 h. So the length for that rectangle will be f of a plus n minus 1 h into the breadth of the rectangle is h. So in order to find the area under this curve and from A to B, we will add all the area of these n rectangles. And as you see, while doing so, we miss out some part of area, that is, here we are missing this particular areas which is under the curve, and hence there will be some error. So to minimize this error, what we will do is we will try to reduce the value of h as minimum as possible. On doing so, we will get the tiny slices of rectangle and hence we will minimize those errors. So to minimize the value of h, we will use the concept of limit and we will do h tends to 0. On doing so, we will get the perfect area under this curve. And the concept of definite integral is that integration of f of x dx from a to b means also the same thing, because this fx represents the functional value at any point x. That means this fx is representing as the length of the rectangle, any small rectangle, and this dx is the small length on the x-axis. That means this fx is length and this dx is breadth, and length into breadth will give you the area of rectangle, and we have to integrate this from x equals to a to b. So this implies integration from a to b f of x dx equals to limit h tends to 0, and here this h is present in each and every term, and there are total n number of terms here. So taking out that h common, then we will have inside the bracket f of a plus h plus f of a plus 2h plus f of a plus n minus 1 of h. So we will be requiring this equation to solve the questions here in this video. And one thing we have to note that is the total length of this area under the curve in x-axis. See here, this point is A and this point is B. That means the length from origin to here is A, and the length from origin to this point is B. So the length from this point to this point will be B minus A. And again, if you see that all these rectangles, I have considered the breadth as h. So there are n number of rectangles. So the total length from A to B should be n into h, because there are n number of h. So that's why this n number of h, that is the length from A to B, should be equal to B minus A. This we have to remember, that n into h equals to B minus A. Question 1. Evaluate the given integral as the limit of sum. So we have to evaluate the given integral, and I have written the formula which we have already discussed. So here it is clear that the value of a in the given question is 1 and the value of b equals to 2. Therefore, the value of n into h which we will require is b minus a, and this is 2 minus 1 which is equal to 1. And let the given function be f of x, that is 3x minus 2. Therefore, using the formula integration from 1 to 2 f of x, that is 3x minus 2 dx equals to limit h tends to 0 h of f of a, and since the value of a is 1 here, so it is f of 1 plus f of 1 plus h plus f of 1 plus 2h plus f of 1 plus n minus 1 into h. So this equals to limit h tends to 0 h of f of 1 is 3 into 1 minus 2, because f of x equals to 3x minus 2. So f of 1 will be 3 into 1 minus 2, that will be 1, plus f of 1 plus h is, let us calculate here separately, f of 1 plus h will be 3 into 1 plus h minus 2. Now this will be 3 plus 3h minus 2, and this equals to 3h plus 1. So the value of f of 1 plus h is 3h plus 1 plus f of 1 plus 2h similarly will be, from here it will be 3 into 1 plus 2h minus 2, which will give 3 plus 3 to the 6h minus 2. So it equals to 6h plus 1. So f of 1 plus 2h is 6h plus 1, and similarly f of 1 plus n minus h, let us calculate it here. 3 into x, that is 1 plus n minus 1 h minus 2. It will be equal to 3 plus 3 into n minus 1 h minus 2. So it will be 3 into n minus 1 h plus 1. So here it will be 3 into n minus 1 h plus 1. So it equals to limit h tends to 0 h of, now here if you see, let us write this 1 plus 1 plus 1 plus 1. Since there are n number of terms, so here we will have 1 plus 1 plus 1 plus n number of 1 separately writing plus and writing this 3h plus 6h up to 3 into n minus 1h separately, then it will be 3h plus 6h plus up to 3 into n minus 1 h. So it equals to limit h tends to 0 h of, since 1 is getting added n number of times, so the value it will be n into 1, that is n plus, and from here we let us take out 3h common from each and every term here, then we will have 3h outside, and inside we will have 1 plus 2 plus 3 plus up to n minus 1. So it equals to limit h tends to 0 h into n plus 3h into, now if you see this 1 plus 2 plus 3 plus up to n minus 1 can be written as 1 by 2 into n minus 1. So here it will be 1 by 2 into n minus 1. So this equals to limit h tends to 0 h into n plus 3 by 2 n into h into n minus 1. Now let us multiply with h inside the bracket, then we will have limit h tends to 0 nh plus 3 by 2 nh, and let us multiply that h inside this round bracket, then here it will be nh minus h. And since we know the value of n into h is 1 from here, so let us put that value. So it equals to limit h tends to 0 nh is 1 plus 3 by 2 into 1 into 1 minus h. So this equals to limit h tends to 0 1 plus 3 by 2 into 1 minus h. Now let us put the value of h as 0, then we will have 1 plus 3 by 2 into 1 minus 0. So it equals to 1 plus 3 by 2, and hence my answer is 5 by 2. Question 2. Evaluate from 0 to 2 x square plus x dx. So here the value of a is equal to 0 and b is 2. Therefore, n into h, that is b minus a, will be equal to 2 minus 0, and that is 2. And let the given function be f of x, that is x square plus x. Therefore, integration from 0 to 2 f of x, that is x square plus x dx, will be equal to limit h tends to 0 h into f of a means 0, so here it will be f of 0 plus f of a plus h, that is 0 plus h, and 0 plus h is simply h, plus f of 0 plus 2h is 2h, plus up to f of 0 plus n minus 1 h is n minus 1 h. So it equals to limit h tends to 0 h into f of 0 from this equation is 0 square plus 0, that is 0. So this first term will be 0, plus f of h is h square plus h, plus f of 2h is 2h square plus 2h, that is 4h square plus 2h. So here it will be 4h square plus 2h, plus, and the last term will be n minus 1 square h square plus n minus 1 into h equals to limit h tends to 0 h into, let us write these terms together, that is h plus 2h plus 3h up to n minus 1h together. So here it will be h plus 2h plus 3h plus up to n minus 1h, and the other terms, that is h square plus 4h square plus 9h square, and at last n minus 1 square h square together. So here it will be h square plus 4h square plus 9h square plus the last term, that is n minus 1 square h square equals to limit h tends to 0 h of, let us take out h common here, so here it will be h into 1 plus 2 plus 3 plus the last term is n minus 1, and from this second curly bracket let us take out h square common, then inside it will be 1 square plus 4 is 2 square plus 9 is 3 square plus the last term is n minus 1 square. So here the value of this sum is 1 by 2 n into n minus 1, and the value of this sum will be 1 by 6 into n minus 1 into 2n minus 1. So let us put it there. Then we will have limit h tends to 0 h into 1 by 2 n into n minus 1 plus h square into 1 by 6 n into n minus 1 into 2n minus 1. So before multiplying with h, that is outside, let us write this as 1 by 2 and n into h here, n minus 1 plus 1 by 6. This h square let us separate with n into h, and let us multiply with 1h inside this n minus 1, then here it will be n into h minus h into 2n minus 1. Now let us open this bracket with h, then we will have limit h tends to 0 1 by 2, this nh is already here, so multiplying with the outside h inside n minus 1, it will be nh minus h plus 1 by 6 nh into nh minus h into, and multiplying that from outside, it will be 2nh minus h. Since we know the value of nh to be 2, so let us put it here. So it will be equal to limit h tends to 0 1 by 2, the value of nh is 2, here it will be 2 minus h plus 1 by 6 into 2 into 2 minus h into 2 into nh, that is 2 into 2 is 4 minus h. So here 2 and 2 got cancelled, 2 times 3, and let us put the value of h as 0, then we will have 2 minus 0 in the first term, and in the second term we will have 1 by 3, 2 minus 0 into 4 minus 0. So it equals to 2 plus 2 4s are 8 by 3, and hence the final answer will be 14 by 3. Question 3. Evaluate integration from 0 to 2 e to the power x dx. So here the value of a is again 0 and b is 2. Therefore, the value of nh will be b minus a, that is 2 minus 0, and that is 2. and let the given function e to the power x be fx. Therefore, integration from 0 to 2 e to the power x dx equals to limit h tends to 0 into h into f of a is 0, that is f of 0 plus f of 0 plus h plus f of 0 plus 2h plus the last term is f of n minus 1 into h. So it equals to limit h tends to 0 h f of 0 is e to the power 0 from here, and that is equal to 1. So the first term inside this bracket is 1 plus second term is f of h, so it is e to the power h plus the third term is e to the power 2h, and similarly the last term is e to the power n minus 1 into h. So it equals to limit h tends to 0 h into 1 plus e to the power h plus e to the power 2h can be written as e to the power h square plus similarly the last term can be written as e to the power h whole to the power n minus 1. And since we have one formula, that is 1 plus x square up to x to the power n minus 1 is equal to x to the power n minus 1 whole divided by x minus 1. So using this formula, and instead of x there is e to the power h, so we can write this as limit h tends to 0 h into e to the power h whole to the power n minus 1 by e to the power h minus 1. So this equals to limit h tends to 0 h into e to the power h whole to the power n is e to the power nh minus 1 by e to the power h minus 1. And since we know the value of n into h, that is 2, so we will put it here. So here it will be limit h tends to 0 h into e square minus 1 by e to the power h minus 1 equals to limit h tends to 0 h into e square minus 1 whole divided by, now in denominator instead of this e to the power h we will expand this using our exponential series, that is e to the power h can be written as 1 plus h square by 2 factorial plus h cube by 3 factorial plus up to infinity, and there's minus 1 in the denominator, equals to limit h tends to 0 h into e square minus 1 whole divided by, now if you see then we can cancel this plus 1 and minus 1 in the denominator, and let us take out h common from each and every term. We will have h, and inside the bracket we will have again 1 plus h by 2 factorial plus h square by 3 factorial plus up to infinity. So here this h and h also get cancelled, and let us put the value of h as 0, then we will have e square minus 1 whole divided by 1 plus 0 by 2 factorial is 0 plus 0 square by 3 factorial is 0 plus up to infinity, and hence the denominator becomes simply 1, and hence the answer is e square minus 1. So this was the concept of definite integral as the limit of sum. So we have completed the definite integrals also. Now from the next video we will do the application of integrals, that is we will find the area under the curves or between the two curves. So till then keep practicing and see you in the next video.